We are now ready for our rock and mineral exam. At least I know I'm ready. I hope you are. Same format as last time. We have 10 minerals, 10 igneous rocks, 10 sedimentary rocks, and 10 metamorphic rocks. So I'll give you a little descriptor of each, show a picture. You can pause this video obviously at any time and spend more time analyzing it. Use your chart, use your previous labs, books, whatever material you can. And so now I'll proceed. So number one is a mineral. It is a green color mineral. And I would actually describe this color as olive green. And I can guarantee that the name of this particular mineral has something to do with this olive color. Mineral number two has cleavage. Will not scratch glass. Almost translucent, transparent. And this particular mineral tastes like salt with cubic cleavage. So I think that's a pretty good giveaway for that one. Number three, despite the mineral form, hexagonal prisms, this mineral does not exhibit cleavage at all. In fact, it fractures. The type of fracture is called conchoidal. This mineral is comprised of glass, nature's glass. Hardness of 7, scratches glass really easily. So this is going to be found on mineral chart number 4. Sample number 4 has what's called basal cleavage, flakes off like pages in a book. A very vitreous luster, very soft, will not scratch your fingernail. And that's sample number 4. Moving on to mineral number 5. Despite its crystal form, this is a metallic mineral. This is our first metallic mineral. And this particular metallic mineral does not have cleavage despite its crystal form. So these cubes right here, applied force to it, hit with a hammer, it will fracture, it will not cleave. Very high specific gravity, very dense, gray streak, gold color, iron rich, very rich in iron. Number 6 is a mineral that resulted from the decomposition of a mineral. This is iron oxide. And the diagnostic feature of this mineral, this can be classified as a metallic and a non-metallic. In this particular form here, this is definitely non-metallic because it's lost its metallic luster. The diagnostic feature that gives this mineral away is a red-brown streak. Okay. Number 7 is often used as a gemstone. Comes in colors like red, black, forms these geometric shapes called dodecahedrons. It is a gemstone. And we definitely saw this in our mineral lab. Number 8 is a very dark mineral, jet black, has a wood fibrous look to it, very mafic, very iron rich, 60-120 cleavage, has a greenish black streak, fairly hard, scratches glass. And then mineral number 9 is metallic. This is the metallic variety of mineral number 6. So this mineral can be classified as a metallic and a non-metallic. Its diagnostic feature, again, is a red-brown streak. And the last of the minerals, this is metallic. This is very iron rich. very high specific gravity. This mineral has so much iron in it that it is magnetic. That is, a magnet will stick to this particular mineral. So that's kind of the dead giveaway for that. So that is the end of the minerals. We're now going to move on to igneous rocks. And with the igneous rocks, I'm going to tell you the composition and the texture and a little about what's in this rock. So rock number 11 is a mafic igneous rock, so its composition is mafic. Its texture is phaneritic, which means it has equal size visible minerals. It's an extrusive rock, extremely mafic, formed underground. It's intrusive. It's not extrusive. I think I said extrusive, but it's intrusive. Formed underground, enough time to grow these nice crystals. So the equivalent of this that would be extrusive would be basalt. But this formed underground, very mafic rock, full of plagioclase and a little bit of amphibole. Number 12, the texture of this is referred to as pyroclastic. Pyro meaning fire, classic meaning material that consists of clasts and pieces. And this is the ejected material from a volcano. Very felsic. This is basically the volcanic ash. So I think that should certainly help out with the identification of this mineral. Number 13. This is an intermediate mineral. Intermediate rock consisting of two minerals. The black mineral is amphibole. The white mineral is plagioclase. So number 13, its texture is phaneritic. Equal size minerals visible to the unaided eye. Its composition is intermediate. And the two major minerals are amphibole and plagioclase. Moving on to number 14. Texture of this rock is glassy and has a very vitreous luster. Its composition is felsic. So glassy rock, extrusive, felsic. Number 15, a very felsic rock, very quartz-rich rock. This rock has an awful lot of quartz in it. Very fine grain, but it is a fine grain phaneritic rock. So this is phaneritic, visible minerals, very felsic, consists of quartz, muscovite, and some white potassium feldspar. Those are the three main minerals in this rock. So look at those minerals on your chart. Very felsic, phaneritic texture. Similar in composition and basically almost identical, but different texture. This is a rock that had a very, very, very long time to cool. It formed the coarsest texture of all. This is a felsic rock. The silver mineral is muscovite. The white mineral is quartz. So again, a very quartz-rich rock, much similar to number 15, but this texture is pegmatite. Number 17 and number 18 I put together here. So both these rocks are felsic. So the igneous composition of both these rocks is felsic. Number 17 has visible minerals in it. Number 18 does not. The mineral composition of number 17 consists of biotite, potassium feldspar, and some quartz. So you can see the quartz really close up here. This rock is felsic, but the pink potassium feldspar is a larger mineral. It's a phenocryst. So the texture of this rock is porphyritic. So this is a porphyritic rock, felsic, consisting of potassium feldspar, quartz, and biotite. This is an intrusive rock formed underground. The rock next to it, number 18, is extrusive. Same composition. This is felsic, but obviously the texture is completely different. And this is what we call aphanetic, no visible minerals. Very felsic, but extrusive. Another intrusive rock, which is pretty cool, and this actually is one that they make countertops out of. So this is actually a piece of a countertop. So I purchased this from a company that cuts rock into countertop. Again, the texture of this rock, because of this white mineral, this is the white version of potassium feldspar. So K-spar, which is commonly pink, is often a white color. So again, the mineral composition of this rock is very felsic. It consists of quartz. The quartz is almost like a smoky quartz in this. The black mineral is biotite. The white mineral is white potassium feldspar. The texture of this rock, again, is porphyritic. And then last, number 20, we're going to concentrate on this green part here. The green mineral is phaneritic, which produces a green rock. So there's olivine in this rock. The dark mineral is just a little bit of augite or pyroxene. This is ultramafic, so we're concentrating on the green part of this rock. This is ultramafic, the texture, phaneritic, visible minerals. And so that ends the igneous rocks. We're going to move on to sedimentary rocks. So with the sedimentary rocks, I'm going to tell you basically what's in the rock. I'll tell you if it's clastic or chemical or biochemical. And so number 21, this is a clastic sedimentary rock. This is the finest grain of all the clastic sedimentary rocks. It consists of clay minerals. These rocks often have very nice rock cleavage to it, so this forms nice layers. Consists mostly of clay minerals. Silt, clay, mudstone, that type of thing. Number 22 is also a classic sedimentary rock. And what's neat about this particular classic sedimentary rock, its red color is due to the mineral hematite. But what holds this thing together is quartz. So this is a very well sorted, wind-blown quartz rock, clastic, sand-sized material. So sand-sized material, clastic, comprised of quartz and hematite. That's number 22. Number 23 and 24 I put together. These are both chemical rocks. They both react to hydrochloric acid instantly. Number 23 consists of microorganisms. It's very soft. You can scratch it with your fingernail. It writes on concrete. Formed in very shallow lagoons, but reacts to acid. Much like number 24, a little bit deeper water, more out in the ocean. This rock reacts to acid instantly, consists of calcite, and contains fossils. So this rock we would call phospholiferous blank. Okay? And so that's number 24. Number 25, this is one of the chemical sedimentary rocks that is quartz rich. There are 3 of these, and we name them based on the color. This particular one is red. These samples are nice red color. So this is a chemical rock, and its sedimentary composition is quartz. This will scratch glass very hard. That's number 25. 26. This is a classic sedimentary rock. It is comprised of quartz, but it's not well sorted. This also has larger fragments of potassium feldspar. So that's what that pink material is in there. That is chunks of potassium feldspar. So this rock consists of quartz, some clay, and potassium feldspar. And so the overall grain size of this is sand, but it's poorly sorted, which means not everything is of equal size. So well-sorted rocks consist of everything the same size. 27. Classic rock. Composition, rounded gravel. So this is rounded gravel, kind of all cemented together. I would definitely call this poorly sorted, but that doesn't really matter for these particular rocks. So there's two varieties. There's an angular variety and a rounded variety, and this one is definitely the rounded variety. Number 28, carbon rich, formed in a swamp, burns, rich in organic carbon. #29. This one reacts to acid but on a broken surface. In other words, you have to break it, you have to take a file. So the reaction to hydrochloric acid of this rock is not instantaneously, it's slow. The chemical formula for this rock is calcium magnesium carbonate. So it's a carbonate rock with some magnesium in it, Mg. So look for that chemical formula, calcium magnesium carbonate. And the last sedimentary rock, number 30, is a combination of broken shell fragments, all cemented together. Again, very rich in calcite, a chemical rock. Some people want to call this biochemical because of the shell, the broken shell concentrations. But it does react to hydrochloric acid because of the high calcite content. And that ends sedimentary rocks. Moving on to metamorphics. So the metamorphics are all in green here. Our first rock, so I'm going to tell you the texture, tell you a little bit what's in it, and tell you the parent. So that should narrow it down. So this particular rock here is full of mica minerals. The silvery shiny stuff is actually muscovite. This does have some garnets in it. You have to really look for the garnets. They're kind of a red mineral. Hard to see with this particular camera. So number 31 is a foliated metamorphic rock. It's the third rock down in the metamorphic grade. And its parent rock is a phyllite. This rock too is also a foliated metamorphic rock. It has a little bit of shine to it, but no visible minerals yet. It really tried to form visible minerals. It's the second rock down in the metamorphic grade. #33. Dull texture. It retains its original characteristics of its parent rock, which is a sedimentary rock. Nice cleavage, what is referred to as rock cleavage. And this is a characteristic that this particular rock picked up from its sedimentary parent. Number 34. This is a non-foliated rock. This rock is comprised of quartz. It will scratch glass. And so this is basically fused quartz. So its parent was a clastic sedimentary rock of sand-sized material. Number 35, we saw its parent in the sedimentary table. Black rock, rich in basically chemical carbon. This is not organic carbon. The sulfates have been driven out. It is a biochemical rock because of the carbon. 36, the highest grade of metamorphic grade in that whole metamorphic sequence. Nice alignment of the minerals. The black is amphipole, the white is plagioclase. It takes this characteristic from the sedimentary rock that went through the cycle. And so this is the highest grade metamorphic rock, and it has banded minerals in it. 37. This rock, its parent, is a carbonate rock that's chemical, that's full of calcite. So calcite-rich sedimentary rocks, when they're metamorphosed, produce these calcite-rich metamorphic rocks. So a sedimentary rock that's rich in calcite is going to produce a metamorphic rock that's rich in calcite. This rock reacts instantaneously to acid. Its parent had microcrystalline calcite minerals in it, and this rock, the calcite crystals expanded, they grew due to the hot thermal water that helped this rock grow. 38, I repeat. Non-clastic was it's a non-foliated rock. So it's non-foliated rock. Its metamorphic composition, quartz. So this is a very quartz-rich rock. It will scratch glass. So its parent, again, was a sand-sized rock, a clastic sedimentary rock, sand size, that was very well sorted. And when that classic sedimentary rock was metamorphosed, it turned into a non-foliated quartz-rich rock where the quartz grains were fused together. Number 39, its parent was one of two rocks, either rounded gravel or angular gravel. And so the gravel fragments have now been fused together. A bit more stable rock. So this metamorphic rock, its parent is a gravel size sedimentary rock. And then number 40, the last of the metamorphic rocks, and the last rock. This rock consists primarily of amphipole material. So this is all amphipole minerals. And its parent was one of two rocks, either a basalt or a gabbro. This rock is primarily 98% amphipole minerals. It is a foliated rock. It does kind of fall under the schist classification. It's also sometimes classified as a non-foliated rock, but in this particular case, it's definitely foliated. So that is the final rock in our rock and mineral exam. So at any time you can pause the video. In Canvas, you will go in and write your choice. You'll actually type it out. And then I will go in and correct and award points based on correct answers. Because if I assign points to these, then it doesn't show up. Or actually in this case, I might actually do a multiple choice. So when you go into Canvas, you'll see the options. 4 distinct groups here. Minerals in blue, igneous rocks in pink, sedimentary rocks in yellow, and metamorphic rocks in green. You have the option of obviously pausing at any time. Go back over these samples. Use your lab charts, your lab manuals, and I hope everybody is very successful. And so that kind of concludes the the rock and mineral identification.